I think we should probably get started now. So thank you everybody for joining us for AI 103. My name is Danny and I am the Marketing and Communications Lead at Arcurve. If some of you have been with us for a while, you'll know that this is our third in our AI webinar series. So we're going to take a bit of a break for the summer and we will resume with AI 104 in September. So watch for that date to be announced over the summer. Just a few housekeeping things. We will have about 20 minutes for questions at the end of the session. Jer and Mike are going to talk for about, I would say, half an hour or so, give or take, and then we're going to have about 20 minutes for question and answers. You can put the questions in the QA function. It should be at the bottom of your screen on Zoom. It's a little Q&A chat box. So there's a chat box function and a Q&A function. Please use the Q&A function for the questions and answers. It helps us keep things streamlined and organized. So I'm going to do a bit of an intro for the guys here. Apologies if this is repetitive for those of you who may have been here before, but we've got Jeremy Blay, and he is our Director of Advanced Analytics. He's got nearly 20 years of experience in AI and ML, working on projects in a variety of industries. And he excels as a data translator, providing actionable insights into businesses. Outside of work, Jer is an avid backcountry skier, mountain biker, mountaineer, and paraglider. And we've got Mike Morley, or Mimo, as we like to call him, because we've got a few mics around here. He is Arcurve's Director of AI and ML. He's started several companies and explored a variety of diverse industries. He's a sought-after speaker about AI ML technology, and you may have heard him speak both on Arcurve webinars and in other platforms. And he's quite active in the startup community here in Calgary and beyond. While he's not at his computer, he's usually mountain biking or enjoying the mountains and the outdoors. I guess you can probably see why him and Jer get along so well.
I like pulling off stuff.
Yeah, they're quite adventurous, the two of them. We have to keep them in line around here. Anyhow, I'm going to stop talking now and pass it over to the real stars of the show and get out of their hair. So without further ado, take it away, Jer.
Thanks, folks. Well, thanks everybody for joining. We appreciate the newcomers and those of you who are back again. As Danny mentioned, this is part of a series that we're doing, really to kind of shine some light on the AI and ML space and kind of where we see things going with our clients and where we think we see things going generally in industry. So just a bit of background, the last session we did was AI 102, and it was drawing a clear line to ROI. And what we had done in that presentation is we've gone through very tactical real world examples of where we've implemented solutions or seen solutions implemented. And that reporting is available. I think Danny can probably post that in the chat. So you can go back and watch the recording if you want. And if you have any questions on that, feel free to ping me or Mike or Danny, anyone really. So we'll talk a little bit today about AI in our backyard. So again, you know, where we see real world examples, where we've implemented real world examples. And then the myth of AI, which is, you know, everything you see and read in the news. There's a lot of hubris around what AI is and isn't, where it really is today. So AI today, and then underpinning that narrow AI and general AI, which sort of gives us a really good foundation in how to look at solutions and who's implementing what. We are not going to do anything over the summer because presumably most folks on this call and presumably Mimo and myself and Danny hopefully will be out in the mountains or outside doing other fun things and not sitting in front of a terminal. So getting that quality time in. Yeah, go ahead, Danny. Actually, we'll turn it over to Mike. He's going to talk about AI in our backyard.
All right. Thanks, Jeremy. Thanks, Danny. Thanks, everyone who's joining. Yeah, so no doubt everyone's familiar with the large companies out there like Netflix and Google and Microsoft and Tesla and so on who use AI and talk about that sort of thing. And that's great, for those sorts of organizations. But the thing that we get most excited about, though, is getting to work with many companies that are not in the big tech companies who are applying AI methods to solving real world challenges across the industries that you see on this list here. In fact, back when conferences were still a thing, and hopefully they will be again soon, I was fortunate. I was at Graph Connect in New York doing a presentation there, and I got to hear AI expert from New York, Hilary Mason, give a lecture on apply AI methods in the graph database domain. And she had a great statement, and she said, the biggest opportunities in AI aren't at the next big startup or at the big tech firms. They're in industry applying AI methods to solving challenges in these areas. Go to the next slide. And that's one of the really fun things about this particular gig is really getting to kind of work in a bunch of different domains. So I'm going to talk about just a couple here that we know there are different things that are going on. So one of the really interesting ones and one of the really exciting ones that's kind of come up lately is this area of environmental social governance. And there's some fascinating stuff going on here, and we've got a few things kind of underway in various states in this space. So one of the ones that I'm particularly interested in personally is this idea of life-centered design for urban environments. And this kind of comes out of the work that I was involved in when I was at Matrix Solutions, which was doing environmental impact assessment work for, characterizing environments before going in and disturbing them with projects and whatnot. So we would analyze the environments, figure out what was there, try and minimize impacts, make recommendations, this kind of thing. This is now being done in a number of different areas, particularly in urban environments where organizations and design firms in the AC space and others, construction firms and whatnot, cities, are trying to characterize urban environments through a series of well-being indicators to understand how to use design thinking and life-centered design to meaningfully improve these sorts of environments. A couple of interesting things that I've seen in this domain in particular are using satellite imagery for characterizing trees and green spaces for, again, informing how to optimize these sorts of land use scenarios and improve the people's health and well-being in the context of those environments. Another really interesting one that's actually being done here in Calgary as well is risk prediction of wildfire. So this is analyzing satellite data combined with urban forest interfaces to inform and create risk predictions about potential impacts due to wildfires on urban environments and making predictions about or helping to mitigate risks of those sorts of things. So it used to be that this stuff was, just the domain of large companies, but it's becoming much more accessible. So if you go to the next slide, and we're seeing it spread to all sorts of organizations. So in the energy sector, there's a lot of exciting things that can be done here. And one area is sort of this idea of meter proving, so identifying meters that need to be calibrated, reconciling sold volumes. And while our main focus, of course, is working with clients and doing client projects, we do also do some interesting work and just for our with our roundtable. So we have an internal roundtable at Arcurve for AI, for the AI practice. And through that roundtable, we do run a series of experiments to sort of explore different algorithms, validate hypotheses about what might work and what might not work and these sorts of things. And Pete Tunkus and I have been doing this for the last 6 months or a year, I guess, almost. And we've got another one of these coming up on Thursday, actually, where we're presenting to the Global Neo4j Graph Conference, where we've been applying some data science and graph technology methods to characterizing abandoned wells. So we've trained a predictive model around that, and we're doing this just to kind of work out some methodologies and figure these things out. Lots of stuff going on, though, in the energy sector on this, and we're very excited to be participating in it on both in these experiments and also with actual client work. Next slide. So mining, of course, that's where I started my career. I have a degree in geological engineering from Waterloo, and it's been really fun for me to kind of see how this stuff's all progressed. My undergraduate thesis was actually in multiple scale image analysis for blast fragmentation. And we're working with a client where they're actually using a program called WhipFrag, which this algorithm was contributed to a number of years ago, and it's still out there and it's still being applied. It's a really nice application. Basically what happens is you take pictures of piles of blasted rock, and it runs it through a virtual sieving process using edge detection, characterization, and then there's a bunch of models that are trained to understand and characterize the blast in terms of quality. Other interesting work going on here, there's mill optimization, which models which help increase the throughput of the mill, reduce downtime and wear. There's grinder predictive maintenance optimizations. And this stuff's really interesting because I drive a Westphalia. It's a 1985 Vanagon. And when I'm driving the thing, I'll often turn my stereo off and just listen to the motor. And I can tell how that motor is doing just by listening to it. Well, there's this one operation that we were working out where they were using a similar method. You can listen to motors and understand the performance. So what they were doing is they were doing acoustic monitoring with just a manual process where somebody would walk around and record these things and then just manually analyze the results and whatnot. Same with thermal imaging. They were doing that with motors. But it's now possible to train ML algorithms to listen to these sorts of motors and whatnot and actually set up a model that says, this is normal, tell me if that changes. Which brings us kind of the next thing with all this. Go to the next slide. Back one. There we go. You hear a lot about this sort of stuff, and this is kind of a nice transition into this whole part of the subject. The real danger is not that AI is going to take over. It's actually the belief that this stuff is more powerful than it is. AI works really well in the context of the sorts of examples that we've been kind of describing. Narrowly bounded, well-defined problems that have certain characteristics that you can build kind of a model around. A lot of times, though, what ends up happening is we get into this hype cycle where these things are oversold, which then leads to people overestimating the capabilities and putting these sorts of practices into places where they shouldn't be. The other area so AI falls over in the implicit information that everybody sort of takes for granted. And there's quite a difference between machine intelligence and human intelligence, and they both have valuable and useful characteristics, particularly when they're coupled together. Current AI technology cannot emulate the plasticity of human cognition. You can take a person, drop them into a different context, and they can apply their knowledge and domain to actually understand and learn the new environment they've landed in. And there's a really great book that I'm reading by a guy named David Eagleman called Livewire. He's a neuroscientist at Stanford that talks about this, how people are actually born unwired. And we sort of, through our understanding our context and our environments, our brains wire themselves up. AI is hardwired. We have to train it. We have to provide it the context for which it's going to operate it. And you see this with the area of self-driving cars and autonomous vehicles, which have been 5 years from now for the last 15 years, I guess. And why is this? Well, it's because there are a lot of edge cases when it comes to driving. Driving is all edge cases. Is that cyclist who's pulled up at that stop sign, are they actually stopped or are they track standing? Are they going to turn left or right? It's very hard to tell. Training an AI to understand that is a huge problem in and of itself, let alone trying to get a car to drive in snow. There are ways of mitigating that, which Jeremy's going to talk about a bit, and there are areas where these sorts of technologies, such as self-driving cars, can be very well applied, which he will also go into a bit more. But context is key. AI can't really adapt to new situations. There's another example with radiology that's come up recently, in which the expectation associated with the way that AI was going to, I think there was a prediction made in 2015 by Hinton, I believe the guy's name was, who suggested that in 5 years, so by now, radiologists would be obsolete. That is not the case. Radiologists are in more demand than they ever have been. And the reason for that is what they found was they trained this model using Stanford data at the hospital there, which gave pretty good results. But when they tried to apply it to other hospitals with different equipment, different procedures, different policies and whatnot, the AI's performance did not live up to expectations. Which brings up another point about these things. Go to the next slide. General AI is not really a thing because it tends to fall over because it doesn't have the context around it. It can't compete with the plasticity of human cognition. A radiologist can go from that hospital, they can go to another hospital, and within a very short amount of time, they're performing as well or better than they did at the place they were prior. You'd have to actually reconstruct the entire radiology model for that specific case in the context of that hospital. Edge cases, I spoke a bit about that. Driving is a lot of edge cases, mostly edge cases, in fact. So if you've got a situation where you're dealing with a problem that's not well bounded and is a lot of edge cases, the AI probably isn't going to work so well for that. Another example is compute. So Pete Tunkus, one of our colleagues on the data science team, he's going to be presenting at the Nodes conference with me on Thursday. We've been training it's actually kind of a neat application, again, being for mining. We've been training a little predictor that does borehole logging predictions for lithology logging. And just to train this little model took, the better part of 24 hours. And that's just for a limited experiment. So the compute associated with these things, trying to get this sort of thing up and running, can be prohibitive if the problem needs to be well bounded, well thought out. And then finally, getting functional AI from proof of concept into production takes considerably more effort, and it's often an area that gets forgotten about or neglected. We believe, and we've seen this, that AI is at the same place where software was back when Arcurve started, in fact. Lots of potential, but lack the process discipline and focus to get things into production and to sustain them. So it's one of the reasons we're really excited to be involved with Arcurve, because Arcurve started with helping software become a reproducible, sustainable thing. And we're now applying the same core concepts and principles in making that Arcurve did to make software projects successful to this domain of AI. Over to Jeremy.
Cool, thanks, Mike. So I'll talk a little bit about where we see AI today, so some of the examples that we kind of have that are sort of germane and to a lot of the audience, and are things that I think maybe people kind of have noticed, not maybe overly so, but it becomes a lot more obvious when we kind of talk about it. So one of the things that works really well, or has worked really well, is the proliferation of audio devices like Alexa, Siri, Google Voice, and voice to text. Those technologies have become much better in the last couple of years. They've become fairly sophisticated in actually writing down what you say and understanding the nuances in language. So that's matured quite a bit. The same sort of thing with autocomplete in email and text. I'm sure everybody here uses Office 365 and sees that, oh yeah, I have these people in the to line, and it auto completes that for you if you can, or if you send an attachment, it'll say, hey, looks like you forgot an attachment. Recommendation engines, I mean, we've talked about this before, sort of ad nauseum. Amazon, Netflix, you name it, like LinkedIn, Facebook, all of those recommendation engines know what you like, what your preferences are, and they've become very adept at doing so. I mean, that's one of the reasons big tech is so big. They've owned those technologies, but the same things are applicable to the bottom three examples here. So supply chain and logistics optimization. If you think of like UPS, maybe again, Amazon in delivering just in time ordering, that's become very sophisticated. That doesn't just apply to like traditional analytics traditional logistics. If you think of like delivery, product delivery, but it also applies to like products that you might be shipping through a pipeline, demand forecasting, a lot of the stuff that we kind of covered in AI 102 last month. And then industrial recommendations, so like facility operations. Mike had mentioned earlier, looking at mill optimization. So how do we put more rock through the mill? How do we put more oil through the pipeline? That sort of thing. And AI as a service. If you think of the top three examples, or at least the top two, many of those components, if you will, or those individual technologies have become embedded all over the place, right? So you can use voice to text as a service. And if you look at if you look at AWS and Azure, they've done that with Azure Cognitive Services and some of the other tools where, hey, I have an OCR engine, I can feed it text and I can, I can feed it images and I can get text or tagging back from it and I can use it anywhere I need to. So the AI as a service has become very prolific, and we see it embedded all over the place. If you think of a lot of these types of applications, they're very nuanced. So, the best AI is the AI that you hear but don't see. It's there, it's suggesting, and it's augmenting the human. It's not really replacing the human. So they're very narrow, specific types of AI that have become mature and that we see applicability in the industry kind of all over the place. Yeah, and in every one of these examples, the human is a part of the loop. As Mike suggested in the slides earlier, these technologies don't replace the human, they augment the human. Next slide. So why AI today is successful? So I think the first key to that is a narrow problem and well-defined outcomes. It's like any solution that gets implemented. What are the goalposts? And having clarity on those goalposts. Usually, we strive to avoid net new processes. There's always a lot of hurdles implementing something net new. And the externalities have to be factored in as well. One of the things that we've seen with the application of ML algorithms in industry is it solves a problem. So like, let's say we go back to that mill optimization problem where let's say for a certain application, you increase the throughput of a mill. But in doing so, you wear out your facility more quickly, or you run out of your feedstock more quickly, or you can't ship the product quickly enough, and you create these other externalities. So really having a well-rounded view of what that solution does and how it implements an optimization in the context of the overall operation is very important. Iterative, this is something that's mature in the software industry. Everybody does agile development now. Nobody really does waterfall. There's a reason for that. And it's the same thing in the analytics world, in the AI world, where, okay, we're going to start with a small chunk. We're going to see that it does the thing that we want it to do. And often, it turns out that the data doesn't either exist, it's poor, non-existent. Yeah, I guess that's kind of all I have to say there. So the next one on the list is algorithm commoditization. So the maturity of these technologies is interesting. If you look at the major 3 platforms and a bunch of the other major platforms, you can implement these algorithms in Python. You can implement them as a service. They're modularized and well understood. So that sort of opens up the door for more standard resources, I guess you could say, to go and implement those algorithms. So it's not so much about writing the algorithm as it is using the algorithm and the fine art of understanding the data that goes in and training and sustaining it. And the big part there is, sustaining it is not really well appreciated, maybe at the outset. And that's something that we've discovered with our clients, is that we can bring a maturity to deploying these algorithms for a lot of our clients. Cheap compute and storage, it's a race to the bottom. You can look at any major platform and you can get 15 different types of storage, hot, cold, and everything in between. And you don't really have to be stuck on a platform. If you look across the major 3 platforms, GCP, AWS, and Azure, a lot of the service offerings in those platforms are effectively the same. They just go by different names. Commoditization of OT, operational technologies. So devices on the edge. Devices have become cheaper just as compute has become cheaper, and they've become commoditized. If you look at, Raspberry Pis are an old thing now, but you can put telemetry on just about everything. So that is interesting because it opens up the door to a bunch of information that was hitherto unattainable or unavailable. Next slide. So narrow versus general AI. So I think this sort of sums up the difference between the myth and the reality. This is pretty common nomenclature. Narrow AI is very much focused on single or limited tasks. So I have a specific problem, I'm going to solve that problem. And that includes a lot of the common ML techniques. So, like standard linear regressions and XGBoost and K nearest neighbor, K means. Those algorithms they solve a specific problem. Those algorithms can also be used compositionally. So you might use 2 or 3 algorithms to solve a problem. And I mean, we see that with the narrow AI with recommendation engines and speech recognition rather, where they do exactly one thing and they do it really, really well. General AI, which is what Mike was talking about when he was talking about the myth, is effectively for a computer to learn what a human can, and the ability to learn common sense. Whether the Turing test becomes applicable in that domain. So that really underscores where the reality and where the myth of AI is. And I think that's just about all we have for today. Danny, do you want to go to the next? Yeah, there we go. So maybe back a slide. I guess we can kind of open up the door to questions if anyone has any.
All right, yeah, we can open it to questions. I'm gonna do this here so that we can see everybody big instead of little in our screen. As I've mentioned, you can pop your questions into the Q&A and we can answer them from there. There's 2 little chat bubbles and it says Q&A, and it should be at the bottom of your screen, just in case you're having some trouble finding it. So feel free to just pop any questions you may have there. I've got one here and it says, what are the most common narrow AI ML algorithms? And I don't know who wants to take that one, Jer or Mike.
Yeah, sure, I can take that. Like, as I mentioned earlier, algorithms like K nearest neighbor, K means, they kind of get used all over the place. Like, those are effectively clustering algorithms, probabilistic clustering algorithms. They work really well with natural language processing. But there's the other standards out there. So like random forest, principal component analysis. Neural networks get a lot of hype. There's some promise there. Convolutional neural networks do get used for image recognition. So the thing that Mike was talking about earlier with identifying the size of rocks on a screen, that's something that can be trained through a CNN. And then I guess probably the other thing I might want to touch on is continuous modeling versus discrete modeling. Modeling a problem at the outset on a test set of data, and then having the modeling as you go and doing it continuously. Mike, do you want to add anything to that?
Yeah, actually, it's interesting you mentioned those two, because we are for the little experiments that we're conducting, and I can talk a little bit about that because we're going to be making that public after the event. But for the site characterization thing, essentially it is a clustering problem. So it's training this thing to kind of using KNN, the K nearest neighbors thing, to start to give a base contextualization of sites, and then applying weakly connected components to that to start to try and rank these things Louvain to further cluster them up into little communities. And then using degree centrality as the third step to that. So this is an example where we are actually combining several different algorithms together to get a net here's a cluster, here's a community, and here's the rank of things relative to each other inside of that community. And that's often how these things go, is you'll have these sorts of recipes that you can follow. So that's part of what the work that our roundtable does, is we have a number of PhD data scientists on the team who help us with, okay, here's a set of problem domains, here are the patterns that you'd use to approach these. It's very much a similar thing to what happened with software development with design patterns. And then that helps kind of people to understand where these things can be applied, methodologies for doing that, and then also testing methodologies associated with validating, verifying that the approach to solving these challenges are going to work using a regular set of standards as best we can do at this juncture.
Awesome. Thanks, Mike. Thanks, Chair. And we've got another one here. It says, I think that humans adapt to new situations better than AI because of a combination of intuition and finding and applying abstract patterns from our past experience to the new situation. Could future general AI have something equivalent to these human features, and could that cause a tipping point in unemployment?
Oh, I'll grab this one if that's okay. This is a really interesting one. So I have a number of people that I talk to about this kind of stuff on a regular basis. We used to do a thing called the sushi sessions, where a bunch of us would get together and have sushi and talk about things exactly like this. So a guy named Trent Gilham was one of them. He's a super interesting person. So yeah, we talk a lot about this. It's like, okay, when is, general AI, the thinking behind some of the stuff that went into our current AI models and the way neural networks and whatnot work, were actually conceptualized in the 1950s and 60s. Obviously, the understanding of the brain has changed considerably, and the thinking about the way human thinking works has evolved a lot since then. The type of AI and ML that we typically do these days, particularly with neural networks and not, is really grounded more in this 1960s understanding of the brain function. These, people like this David Eagleman, and there's a whole pile of interesting research that's going on the side of neuroscience. And I'm obviously not a neuroscientist, but I know people who kind of operate that domain that we have chats with. One of the things, and this is kind of why I'm super interested in the graph database stuff, is because it provides a fundamentally different way of modeling data that is a lot more like, the way somebody's memory may work. I mean, it's a huge simplification over what a neuron actually does, obviously, but at least it's a start. And the more we can kind of store data in a form that's closer to the actual way this stuff is in reality, the better these downstream models and the way that we actually start to process this stuff into these other machine learning methods is going to be. And one of the areas where we do actually use some of this stuff already is something called a concept graph. That is like an ontology that you can give, and there's a few of them out there. There's one by Stanford and another one by Microsoft that's got something like 50 million concepts in it, which is still very, very small, but it's still quite useful, because you can then at least say, okay, this bit of text coming in is from this domain, therefore we should route it down this path. That's how you kind of get out, you can bring the general stuff into a more specific case and then route it in the right direction. Personally, I think we're still quite a ways off. I did get to see Peter Diamandi's lecture on this subject, and I've read a number of Ray Kurzweil's books, Singularity and those sorts of things. I think Kurzweil's thing was either 2029, or I think he's moved it back again, but I think we're still quite a ways off from this really having an impact in the sense of being able to replace humans in the context of a lot of the jobs that they're doing. But it's going to be this increasing context around modeling the domains and the specific domains that's going to help a lot with that, I think.
Yeah, I just want to append to
That
that
made
a
sense.
little bit there too, Mike, if that's okay. Yeah, I'll just drop there's a BCG article that came out rather recently on unemployment and the effects of AI on the employment pool. And I mean, obviously tech is a big, massive draw on the workforce. So there will be, it's the hottest place to work, right? So not enough people there. But there are other spaces like retail, which there will just be less retail. We already see, I mean, everybody already sees that with self-service checkout. If you look at any bank, any retail organization, like, they don't want you to talk to a person. They want you to interact with their system. That's what they're all trying to do. So any customer service or very discrete step tasks that an employee has to do, that's where the employment hit will be felt. That said, there are other service industries that are somewhat unaffected. Anything where you're really selling the experience of walking into a brick and mortar store, that kind of hasn't gone away, and that's not really going to be very easily replaced, right? And often, as far as retail goes, I think for a lot of folks who are like, if you're shopping, you sometimes want the comfort of having someone come and talk to you, and we're human still, okay? So I mean, that's not really going to go away.
And just to finish that, that's a really great point, actually, the human thing. Douglas Engelbart, who was better known as the creator of the mouse, his main contribution though was quite ways beyond that. He created a thing in the 1960s called Augmenting the Human Intellect. It's a really interesting set of papers and studies to read, which culminated in a 1968 demo called The Mother of All Demos. It's on YouTube. It's great to check out. He was very much, there was kind of a split between the artificial intelligence community and the augmenting intelligence community. Engelbart was part of augmenting intelligence. That's where we see the most immediate benefits and improvements, is in that side of the fence, in terms of helping people do their jobs better by doing a lot of the kind of the grunt and frustrating work, and taking away things that are repetitive and not high value, rather than trying to fully replace people in their jobs.
Yeah, sorry. I do want to add a little bit more to that. I know we've gone rather long on this. But yeah, I mean, there's other initiatives out there where, so like Q&A for analytics and reporting. So being able to ask, how much money did I make last quarter? Which is a pretty hard thing to do, because again, AI doesn't really understand context well. So there are certain types of analysis like that will not easily be replaced. And it's still a growing space. But not to belabor the point, but we should move on to the next question.
I don't know.
That was a fun one.
That is a good one. I would always much rather talk to a human. I'm the one that hits 0 as soon as I call any kind of automated answering machine robot, because I like my humans. All right. I've got another one here, and it says, how do you go about identifying what opportunities exist to get value from AI for an organization?
So we have a discrete framework for identifying the opportunities, and it starts with the stakeholder engagement, and it's like all of this stuff is about outcomes. It's not really about the analytics. It's not about the AI. It's okay, like, does this drive an ROI? Or am I going to make more money or lose less money if I do this? So clearly identifying those outcomes, and engaging with the leadership to make sure that they're clear on those outcomes. I think there's a bit of coaching that kind of goes on there, because sometimes the outcomes are hard to achieve for various reasons, whether they be the people, because people are sort of a hairy problem, or the data. The data value stream is sort of the second step in how we've kind of codified that. And do you actually have the data to do the thing that you want to do? Because often what happens is we'll have a client that'll come out and say, well, we want to do an ML implementation that solves this problem. And it turns out that, actually there's something adjacent or something near what you had intended that achieves the same results or better results or more low-hanging fruit.
Mike, did you have anything to add to that one?
No, I think that covers what
awesome. I think we've got time for about 2 more. So I've got another one coming in. It says, can you contrast ML targeting transactional type data versus real-time data, RE data volume impacts on algorithms used and processing learning time cycles?
Ooh, that's interesting.
That's a good question. Well, I'll kick that one off. We're living in that world presently.
Pretty much.
So yeah, there's a couple of interesting rubs there. So the traditional way of doing like data warehouses and analytics, self-serve analytics exists. People have sunk, organizations have sunk a lot of capital into building out data warehouses and those solutions. And then all of these platforms come with streaming solutions, which works very well for OT. And sometimes we see clients with sort of almost a siloed approach where they have the legacy stuff in one place and the streaming stuff in another, and they don't really talk or work very well together. As far as I think the proposition of streaming is a little bit overpromised by the big vendors. No one really cares if you can get your tags from your OT system into your cloud platform in 1 minute or 2 minutes. It's whether or not it's 5 minutes late or 10 minutes or 15 minutes late. Most of the algorithms that we see that have been deployed successfully are trained on testing sets of that live data, but they run discretely. So they run at a 5, 10, 15 hour interval, and they make recommendations to an operator. So the streaming sort of matters in that it's functional and resilient, but the speed at which the streaming matters isn't really like a deal breaker.
Yeah, we did actually get a lot of experience in that. So one of the observations I think that Jeremy's kind of alluded to there too is, that was kind of the whole premise of the Menome platform as well, was basically before we got acquired by Arcurve last fall. But we were very much focused on streaming analytics, and there's a lot of really interesting stuff going on in this domain, where being able to ingest data from many different sources and bring it together, you have a number of advantages if you do use a streaming pattern rather than a traditional ETL pattern. So one of the things you could do is you can actually atomize the data at the sources, turn everything into messages essentially, stream them in, and then combine them together. And again, one of the reasons I do like the graph technology, although now you can do this sort of things with Databricks, and there's a few others out there that do this kind of stuff too, is you can basically continuously merge and integrate the data from all these different messaging sources coming in. And we were able to get that up to a throughput of about 15,000 messages a second being continuously integrated from quite a large number of sources into a net resulting knowledge graph. From the knowledge graph, then you can run processes that pull data up into various graph data science algorithm modules that are now available inside of that particular environment. Same sorts of things that exist in Databricks, of course, where then you can actually trigger model rebuilds on a cadence. So basically your knowledge graph gets updated by these different sources, which provides you different, changing insights and whatnot. You then rerun the model generation. Ideally, you run that through a series of tests. And then once that model is completed its updates based on the telemetry that's coming in, you then republish that model. So then it drops into the production side of the equation and is now available to actually factor in updates with respect to the stuff that's been fed into it. That's still, there aren't a large number of use cases that would fully take advantage of that entire chain as yet, because it is fairly, there's a lot of work involved setting all that up. So typical model refresh rates, I think, don't happen all that quickly, as Jeremy's indicated. You're maybe doing it on a cadence of maybe monthly for most use cases. So, unless you really need a tight feedback cycle and your model's relatively small, then this stuff is still not that commonly used, at least in some of the applications that we're seeing at present.
Yeah,
I do like the streaming pattern though. It's my personal favorite.
Well, yeah, I mean, like I think the streaming pattern is sort of where everything is going, right? Because like it'll become the default, right? I mean, if you look at Kafka, it's sort of used everywhere. Yeah. All of the major platforms all have streaming hooks. It's becoming almost like what a RESTful API has done for the software industry. And I mean, like we see a lot of clients where they're either being asked to provide their data or they're consuming data from one of their vendors. And it's kind of like, okay, give me a stream of your data. I think in the project execution space, probably the more challenging components are really data quality and I don't know what you'd call it, like data reality. Like, so, but if you have a facility and part of that facility is down, the model is not taking into account what's actually happening on the ground. And it's delivering recommendations to an operator who's looking at his machine and saying, his or her machine, and saying like, well, that's not what's happening. So therefore, I'm not going to use your recommendation and trust as eroded. And that's kind of where it falls over. And the other thing I'd probably add to that is there has for a long time been a big, wide gap in OT, operational technologies, and IT. Where the OT world, the SCADA people, the PLC people, they live in their own island. So I think that gap is becoming narrower, mostly because these ML initiatives need that data, or need a lot of that data, and those loops are becoming smaller.
Yeah, a lot of challenges with vendor lock-in in that space, because it's the PLC domain in particular was been around for a long time, and that was kind of the primary business model, was the proprietary systems that kept the data internal. So it's another spot where some of these harvesting streaming type patterns can help, because you can extract the data out of those various things and then project it into these other places. One last thing just on the streaming thing is it's also got a lot of advantages with flexibility. Like it's one of the hard things about ETL, like traditional rigid ETL pipelines, is they tend to be pretty brittle. And you don't have good rollback control. And also if something fails, it fails the entire batch typically. Where with streaming, one of the things we were able to accomplish with that is you can actually have a bunch of things kind of watching the data as it flows by, and then taking actions kind of adjacent to that stream of data. It's like, taking a sample out of a river. You're not disrupting the flow of the river. It just kind of keeps on going. So there's all sorts of great things that you can do, in the context of that. Adding things in for monitoring without affecting kind of the stuff that's already dependent on the stream. So it's quite a powerful paradigm in a lot of ways. So we do like it quite a bit. And yeah, like Jeremy said, there's Kafka and there's RabbitMQ, who's kind of adjacent but slightly different technologies for handling all of that.
Awesome. Well, I think that leaves us at about time. I'm just going to share how you guys can get in contact with us if you would like to continue any kind of conversation with Jeremy or Mike. And I want to thank you guys again for joining us for AI 103 and remind you that AI 104 is happening in September. And I will say now to have a great summer, get outside, enjoy connecting with people again. Hopefully things are looking up a little bit and enjoy what is looking like it'll be a good weather summer. So thank you, Mike and Jeremy, for joining us today. And we will see you in September.
And yeah, before I got one more presentation to do, and then I can also do less. That's on Thursday, nodes. That's a Neo4j thing, so you can check that out too. Pete Duncan and I will be presenting at that.
And you can find a link to that, I believe, on our LinkedIn. So if you want to go check that out, and Mike's probably got it on his own personal LinkedIn as well. So
I think so.
Maybe. Awesome.
Cool. Well, thanks everybody for attending, and thanks, Danny, for hosting.
Awesome. Thanks, guys. Take care.